So yeah, first of all, just a couple of rounds of thanks. So thanks to the organizers for the chance to talk today. Thank you to all my coworkers and colleagues, current and former, who have been doing a lot of work trying to launch some programs with the CHIPS department. And thanks to all of you for spending a little bit of your afternoon here to hear me talk about my favorite subject, which is the work that's going on with the CHIPS team, the Department of Commerce, launching a lot of exciting programs. Before I really dive into that, however, and that work broadly, which with the CHIPS program is really thinking about the future of the industry, the future of manufacturing and technology and innovation in the United States, I want to start by looking backwards a little bit and how we got to this point. So I want to give a little bit of a brief history of the semiconductor industry. I want to talk about a paper that put forward some ideas and some concepts, and in some ways were just some observations, but that not only sort of captured people's thinking, but that actually changed the course in some ways of the industry. But I'm not going to talk about this paper, so not the Moore's Law paper. You've heard that talk before. I want to talk about a different one. That would be the long history of the semiconductor industry. I want to talk about a short history. And in particular, I will argue that someday when somebody's writing this book again, we're in the middle of the most interesting chapter. And I will argue that that chapter started in January of 2017 with this paper. And it was written by a group you may or may not have heard of, PCAST, so President's Council of Advisors on Science and Technology. And maybe you've served on committees before, these councils, and you write reports and you wonder, is anybody ever going to actually read this? Or maybe that's just a DC thing, but if you come to DC, you'll get put on a committee and you will write a report and wonder if anybody's going to read it. This one people did, because this paper in a lot of ways said some things that really resonated, but weren't necessarily popular at the time. People weren't a lot of times willing to go on the record and say them loudly. So just to pull a couple of quotes from this paper, which said a lot about investing in the future and investing in R&D and innovation and how we needed to, stay ahead, and keep, that sort of leadership, technology leadership. But they also said, any presumption by US policymakers that existing market forces alone will yield optimal outcomes, particularly when faced with substantial industrial policies from other countries, is unwarranted. There had been sort of decades of conventional wisdom, which is, hey, this is a huge, win and just a huge demonstration of what market forces can do and what sort of unleashed innovation can do. We don't need your help. We don't want your help. Let us continue. But when you start to see trends like the manufacturing trends, globally, and you want to do something about those, it's a little bit hard to make that argument when it isn't really a free market in a lot of ways. Wasn't so popular at the time. Another thing that they said was really about innovation, and that the US does facilitate innovation. It's not just ways to cut costs for existing technologies. And historically, government research, government-sponsored R&D has been essential to driving semiconductor innovation. That's great. We should continue to do that. And they outline lots of ways to do that. But that support would be unsustainable if industry is hollowed out. This really resonated with me personally. My graduate school work was in display technology. I saw that technology, go overseas. And very soon, the best research groups in the world were no longer in the US. They were, as I was going through grad school, and it wasn't any longer true. So sort of extrapolating what could happen with semiconductor technology, particularly with process and manufacturing technology, was certainly something that resonated with me as well. So this report was published. It made its way around DC, around sort of policymaker circles, and people really did pay attention to it and started to ask, well, what should we do? And one of the quick answers was to, there we go, to give money to DARPA. And this is another thing that's near and dear to my heart. So I was at DARPA at the time as we were kicking off the Electronics Resurgence Initiative, which, sort of initially kind of right away, were able to get a year's worth of funding to put towards, semiconductor, commercially relevant semiconductor technology. And so we made a big splash, probably a little more than we should have for just $75 million. However, we thought there was a good chance that within the next budget cycle, we were able to make a bigger announcement of $1.5 billion of funding over 5 years into research for semiconductors. So it's a 5-year program. Sort of one of the taglines, a more specialized, secure, and heavily automated electronics industry, can certainly relate to automation at this conference, which certainly design technologies were a big part of the program. Security was actually an even bigger part of the program, or at least a bigger objective, because there really was a question at the time when you're trying to sort of think around the corners, what do we do if there's no longer advanced semiconductor manufacturing in the US? How would we deal with that? So launched a bunch of new programs and really did create a lot of new projects and partnerships with commercial companies working with the DoD. And was very happy to see ERI 2.0 was launched. So this sort of continued investment in semiconductor technology continues. But as I mentioned, this was just a thing that we were able to do quickly. It can take a little bit longer to figure out what the longer term solution is. And so behind the scenes, and there's probably a whole subchapter to be written sort of between that 2018 and 2021 timeframe about the development of the CHIPS Act. So CHIPS and Science Act was introduced in 2021, enacted in 2022. And since then, a lot of activity. I mean, we won't go through all of these bullets. I'm going to be talking a lot more about that. But really, you're seeing the launch of this new program that's really meant to sort of bend the curve of this industry from the lens of some of the things that PCAST was talking about. So those are things that, sort of proactive things that we've been doing in terms of funding and sponsoring innovation in manufacturing. It's important to note that that's not the only part of the story. There have been other things that actually were able to move relatively quicker, which were sanctions and export controls. And really doing things in a way that were just very new, very, sort of uncharted territory. But things that people felt were really important in terms of just sort of global competitiveness. And so even going back to as early as 2018, started to see some sort of targeted sanctions, but really bigger headlines started to be made in 2019. Of course, everybody remembers Huawei at sort of the 5G systems level. But then you start to realize that, with access to commercial technologies, there's only so much you can do. And so you start to see these sanctions get deeper and deeper into the industry. So SMIC, so foundries, you start to see tools, design tools, EDA technology, and AI chips themselves, as well as memory. So there's really been sort of a separate and parallel evolution here. So you think about these things all together. And when you're thinking about semiconductor industry and you're sort of thinking about, different eras, and you're usually thinking about technology and how technology has changed, this is a pretty unprecedented era. And so, this is the sort of the world that we're stepping into as we're developing these new programs. And some of the impacts we can already start to measure. And I will say, as somebody who, from that time was really concerned about the trajectory of the domestic ecosystem, this is really rewarding to see. So among other things, according to SIA, you have data here of over $200 billion in investments that are announced, and this isn't complete. This is just, among their membership. And more recently, analysis showing that by 2030, the global share of leading edge manufacturing will go from 0% today to 20%. And so this is already, again, just early returns, and it's not, you may hear and pay the most attention to the big names, the big announcements, Intel, TSMC, Samsung, Global Foundries. If you look at the map, it's a lot more than that. right? It's legacy, current, mature, it's supply chain. So there really is sort of up and down the stack, a lot of new activity in a way that you wouldn't see a map that looks like this, in any other era over the last couple of decades. So we're starting to see some of that impact. It's not just in the US, of course. There are similar efforts going on around the world. And I think just this whole sort of era of manufacturing and realizing the strategic importance of this industry has really grown. I do want to talk a little bit about technology. I mean, that's normally what we would talk about. If you say, hey, what's been going on in the semiconductor industry for the last 7 years? I'm going to do this at a super high level. But if you just think about sort of the various parts of the industry, an obvious one would be state-of-the-art logic technology. Been a pretty consequential couple of years. Gate-all-around transistors were introduced. That's a pretty big milestone. What's even more interesting is that in the span of just a few years, if you go back to 2018, I think it was pretty universally accepted. TSMC has overtaken Intel in process technology. Not only that, but until very recently, just conventional wisdom is not only have they overtaken Intel, but it's over. There's no way you can catch up. They have such a big market share. They have such a lead. They're executing so well. I will leave it to the marketing departments of the two various companies to debate which process technology is better at which particular moment in time. But just in that short amount of time, it's a race, and it's going to be pretty interesting to watch over the next few years. Advanced packaging, again, the last 7 years, incredibly consequential. We all sort of understand at this point how important this is going to be for technology moving forward. And so, again, think back, it wasn't that long ago that the first, sort of heterogeneous package was introduced to the market in the form of an FPGA. Since then, we've seen CPUs, GPUs, and even consumer products that are truly employing, 3D and advanced packaging technologies. So that field is just continuing to take off. AI, hardly need to talk about this, everybody understands, but we've sort of gone from the PC era to the mobile era to the data center era. Now we are in a new era. That has happened just in the last couple of years, just in terms of investments in data center technology is a big part of it. I know you can't read this plot, but if you look at just the size of the models over the last 7 years, even over that short amount of time, you can see just the exponential growth. And while people will continue to see how much you can do with smaller and smaller models more efficiently, as they should, it is still true that the most powerful and most capable models are the large ones. So, certainly a trend you can expect to continue. Just market, what's happening in the market. I thought this was pretty interesting, just to pick a couple of hardware companies. We have spent as hardware people, had a little bit of an inferiority complex, if you're not in software, you can't be sort of one of the big high-flying stocks, that kind of thing. Well, some hardware companies doing pretty well these days. So I made up a new term, the Magnificent Six, which is, the Magnificent Seven, but taking out the one hardware company. And hardware is doing pretty well. However, the data on the right is looking more specifically at venture capital and startup investment. And you can see venture capital is doing pretty well, but the green line is investments in hardware startups. And it's pretty flat. So, there is still a bit of a challenge, and maybe it's a lagging indicator, but still a bit of a challenge to be a hardware startup these days. And in fact, the headline at the bottom is just from a couple of weeks ago with TSMC, Kleiner Perkins, some others, actually starting a new fund specifically on manufacturing, hardware manufacturing investments. So maybe turning a corner, time will tell. Memory, people get mad at me when I say not a lot has happened in memory in the last 7 years. I think there's certainly a lot of progress, but it's along sort of the trajectories that we knew about. So hybrid memory cubes, high bandwidth memory, preceded the cutoff that I invented. So, certainly seeing continuing, progress on a couple of different vectors. Interesting to note that SRAM density is the one sort of outlier, hasn't scaled in a couple of generations, which is a potential opportunity for disruption. But otherwise, lots of progress sort of, again, along those existing trends in the memory industry. And last but not least, interconnects. The last sort of important part of a system. Continuing exponential speed up. So again, sort of along the same trajectories. And if you were like me and 7 years ago, you would have said, oh, we'd be sort of around a corner and we'd be having more photonics closer to the chips by now. You would be wrong, like I was. I think we'll still get to that, but copper appears so far to be the silicon of interconnects, meaning you'll squeeze every last bit you can out of it before you go do anything else. And we're still, I think, on that part of the curve. And last but not least, just public awareness. There's just been sort of a shift just in the general awareness and sort of conversation around this industry. I joke, but not joking, that for the first time in my life, my uncle and my mother-in-law know what I do for a living. People just understand this stuff now. They understand this industry is important. Chips are important. Semiconductors are important. This is a thing that we need to care about. You don't have to be a technologist or an engineer to care about these things. So I do wonder and worry sometimes about short attention span problems. This is a thing that gives me hope. That people sort of fundamentally understand in a new way. We are now sort of a part of the conversation. How important this industry is to our everyday lives, to our economic and national security as well. So I think it's a pretty interesting chapter. Not sure exactly how it ends, but we are starting to think in the CHIPS program about how we can then take a lot of these trends and continue to carry them forward into the future. So I'm going to spend the rest of my time talking a little bit about the CHIPS program. First, just very sort of high-level setting of the stage, because I'm going to focus down into the NSTC, which is near and dear to my heart, but just generally speaking, Chips for America, $52 billion. Most of the attention in the news comes from the $39 billion in manufacturing incentives. So mainly focused on onshoring, reshoring, manufacturing from leading edge, current and mature technologies, supply chain technologies. Then there's $11 billion also with the CHIPS team at the Commerce Department focused on R&D. So I'm going to dive into that one a little bit more. And then a very important $2 billion for the DoD, which is funding what's called the DoD Microelectronics Commons, focusing again on semiconductor R&D, but particularly things that relate to national security applications. So we'll dive into each of these a little bit more. Want to just briefly mention what's happening on the incentive side. Really amazing progress. You may have seen some of these announcements over the last few months. Many more to come over the coming year. But again, up to 10 preliminary memorandum of terms with companies, again, from some of the biggest names to some of smaller ones that you may not have heard of that are more supply chain companies. Now diving a little bit into the $11 billion for R&D, there are four programs that were specifically carved out in the CHIPS Act. So I'm going to spend most of the rest of my time talking about the National Semiconductor Technology Center, or the NSTC, but want to just briefly cover the full landscape. So I think there was a lot of foresight in the people putting this legislation together to actually make sure that they carved out funding in a special program for advanced packaging. The concern being, hey, this is really important. If you just lump it all together, packaging sometimes gets short shrift, and we want to make sure that we're investing in this really critical technology. So the APMP is explicitly called out, and they are really focusing on accelerating innovation, next generation technologies, focused on commercial semiconductors, and how to stimulate further innovation and then manufacturing of that in the United States. Manufacturing USA program. So we've announced a Manufacturing USA program specifically focused on digital twins. I think that's going to be a very impactful program. The proposal due date just ended. Proposals are in and being evaluated now. And really look forward to thinking about how the digital twins technology can sort of fold into and integrate into the NSTC from a community, from a consortium perspective, and make sure that we are building leadership in that field, but also taking advantage of that technology here in the US. And then the last program, at least on this chart, not last in any other metric, but the last program is metrology. So NIST, I think, is a little bit of a hidden gem in the US government. Some incredible scientists and technologists that work there, focused on very hard science problems with respect to measurements, standards, things like that. And what this funding allows them to do is really focus on some of the problems of the industry, work with industry, make sure that some of those new technologies, some of those new challenges and innovations are getting sort of out into the world, and that US companies are able to leverage all of that technology. So when you sort of take all of these together, we really think about the NSTC as being sort of the centerpiece. We want all of these technologies, whether it's packaging, whether it's digital twins, whether it's metrology, to really work together with this NSTC as a way to get it sort of out into the community. And I'll sort of explain how we expect that to work through a little bit of a picture, because the NSTC is a little funny. I'm going to go ahead and build it out. And people sometimes don't really understand how it works. It's a little bit confusing. What is it? How is this? Are you just funding research programs, or is it a place? What is it? It is a consortium. So that consortium has been created. It is now sort of an official entity. It was created through an agreement between the members of the steering committee, so Department of Defense, Commerce, NSF, and Energy, as well as an industry representative, sort of officially launched this consortium. That consortium is initially funded through the CHIPS Act, so through us. So I sit in that little CHIPS R&D office box, and we are sort of helping to stand this up, funding them, providing oversight and support. But at the end of the day, the NSTC is going to be run by this company, we call it an operator, by NatCast. NatCast is a private independent company that's going to operate the NSTC. And so they have been stood up. They have board of trustees, CEO, building up their own internal team as we're building up these programs. And so really the execution of all the things I'm going to be talking about will not be by us. It will be through NatCast. They'll have advisory boards. They'll have at least a technical advisory board, a workforce advisory board, not telling them what to do, but giving advice. They will have facilities, they'll have programs. I'll talk about both of those things a little bit more. And really the essence of it all is members. Members are the people who, and we hope certainly all of you will consider being a part of this program, that will be taking part in these programs, in these activities, in these meetings, using these facilities. And we want to make sure that the NSTC is well coordinated really across the government. So, it being a way to help connect people who don't sort of track the inner workings of the government. It could be hard to track all these various programs at different agencies, and have that be a place where we're working well and collaborating and not doing duplicative work with the other CHIPS programs, with other government agency programs. So that's a little bit of a map, of a layout of how the NSTC will work. Talk a little bit about why we're here and what problems we're trying to solve. There are a few of them, but the one that I start with is this sort of getting innovation to commercialization problem. So this is sort of the classic, lab to fab, valley of death kind of chart, where the message here, at least to me, is I think we have a long and very successful history of federally funded science programs in this country. They've done great work, they have a great history, and I hope they continue to grow and to do what they do well. So we shouldn't just be doing more of that. Our job is to think about where there are gaps, where there are challenges, where there are things that we don't necessarily do well, and think about how we might do things differently. And so one of those things is really that challenge of getting things from an invention to commercialization. So less on the sort of root science innovation, invention, and a little bit more on mature, higher up the maturity scale. There are others. There are certainly barriers for startups. I mentioned that, whether it's chip design, process technology. It can be challenging to be just a startup in this hardware space. Getting access to advanced technologies for prototyping, whether it's getting designs made at advanced nodes or having an advanced process where you can test some new material, tool, something like that. And then workforce. Workforce is really embedded throughout all of the programs across the CHIPS Act, and I think people sort of understand pretty well. I'm not going to make the case here. We have a challenge if we're going to sort of restore this manufacturing trend in the US. We need people. We need innovators. We need the next generation of scientists and engineers. So to address these problems, we've talked about a handful of programs. Not all of these are launched and kicked off, but these are things that we fully anticipate to be part of the offerings of the NSTC. So I'm going to dive into each of these pretty briefly and try to give you a little bit of a sense of what we're trying to do in the program. So I talked a little bit about that sort of valley of death problem. So funded research, again, I think industry has a pretty good handle on where they're going over the next 3 to 5 years. So we're going to be trying to look a little bit out past that. Maybe not the 20-year foundational inventions, but trying to take some of those things that otherwise may be stuck in that sort of 10-year future and try to bring them in. So just funding research and continuing to innovate and looking at investment opportunities that are not generally covered by other government programs is a big part of the program. However, we have a new sort of group of projects I want to dive into just a little bit, because when you think about investing in research, and we're going to have members and technical advisory boards and this research strategy, the problem is we don't have members yet. We don't have a technical advisory board yet. And so as these things build, it's probably 2025 by the time we're launching these R&D investments. And nobody wants to wait that long. So we're kicking off a handful of programs this year in 2024. Their goal is different. The scope is different than what we will be trying to do with some of these longer term and more strategic investments. We just want to get things going. We want to start to see if we can fund some things that may have some relatively early impact. Build sort of that muscle for NatCast of actually running competitions, of putting out calls for proposals and getting people on contract and managing programs. So plan to have a couple of these over 2024. The first one we've announced just had a webinar on it. When was that? Friday. And we'll have a proposers day in the next couple of weeks. You will see how to sign up for the NatCast newsletter and get more information about that later. But certainly this one is relevant for this conference. The intersection of AI and chip design is obviously a pretty popular topic these days. We thought it would be a good idea to dip our toe into this field, learn how to manage data sets, learn how to manage these kinds of programs. However, doing something in this space by just dipping your toe in it can be kind of hard. There's just so much going on. We don't want to be duplicative. However, design of RF circuits seemed like an area that is getting less attention than some of the bigger sort of generative AI topics. And so we are very interested in new tools and technologies for increasing automation and lowering the effort and improving the outcomes of design of RF circuits using AI technologies. So if you're interested, again, please check out the NatCast website, consider attending the Proposers Day. There are a couple of others that we have announced. They'll be coming a little bit later. One is test vehicles. I think a lot of people in the sort of R&D community understand that you don't just sort of go straight from your idea to something that you're manufacturing, and even just to do research, you can spend half of your project time and budget just designing the thing that you need to do the research on top of it, whether it's a test circuit, some physical structure, whatever that may be, just the protocols, the software to run the things. And so the idea, and then by the time you've done all that work, by the way, you're going to publish it, and you did it a little bit differently than everybody else, so it's really hard to benchmark. So the idea is, can we take some of these test vehicles that are really useful for some common problems and for sort of communities more broadly, and create test vehicles. These might be chips, again, with the harnesses, the protocols, the circuits, that might be used by entire communities, and make those available to all of the NSTC. So I really hope this is something that we continue to do by getting sort of more input and being sort of a rolling program. But we'll be looking to kick off a couple of these quickly. And then just one more that I will mention is PFAS. So PFAS, again, an environmental concern across a number of different industries, but certainly something, a class of materials and chemicals that's used in manufacturing semiconductors. The problem is we don't know how to not use them. So replacement and sort of completely getting rid of them in the industry is a great challenge. It's a long-term challenge. And one of the questions we wanted to ask is, how could we have an impact more quickly? So what we will be looking for are technologies for abatement. Can you capture and destroy these chemicals before they're released into the environment without actually having to alter the process technology itself? The hope being that you can actually see quicker adoption and earlier impact. So that's funded research. Quickly to go around some of the others. There's the Workforce Center of Excellence. This is something we'll be excited to be making some announcements on relatively soon. The main thing I will note about the Workforce Center of Excellence is it's not just scientists and engineers and sort of that next generation of researchers that may be participating in the NSTC. It's actually all of the needs of the industry. So it's technicians, operators, people with community college, 2-year degrees, that kind of thing, and really trying to have sort of an enduring body that captures best practices for training across the gamut, including doing a better job of connecting skilled, trained PhDs, postdocs to opportunities. Foundry and facility access and infrastructure. Sorry, can I go back? There we go. Also very excited to be announcing some things on infrastructure as soon as we possibly can. A fundamental question people sort of ask is, what is it going to be? Where is it? Is it one place? Is it 10 places? And I think having a place to do the research is actually one of the real fundamental barriers that we get, that we hear over and over again. So how an infrastructure strategy can help solve that is something that we are working on as we speak. Member services, maybe not so much a program like the others, but I think an important part of membership. This is really a way to, again, just make it a little bit easier to participate, to make sure, we just want to make sure that people are aware and taking advantage of the resources that are available to them. There will be an investment fund that was specifically called out in the legislation. So there is, again, it's kind of a mismatch between being a hardware company and the traditional venture capital model. So we want to think about what we can do to make it easier and higher probability of success when you are considering starting a company in hardware technologies. And last and maybe most relevant to this conference, Design Enablement Gateway. So really a program to make sure that design tools, IP, those environments can be easily accessed, particularly, I think where the biggest impact may be felt are for smaller entities, research groups, small businesses, things like that. So, what does the future look like? We definitely are thinking about this. I'm not going to go through all the details of the slide, only to say that, it sort of depends on who you are. People say, well, what's the value proposition? Well, it sort of depends. And we really are trying to tailor these programs and their value to prospective members and make sure that we are solving problems, real problems that people have. So, close to wrapping up here, just want to talk a little bit about sort of what we've done, but also what's to come. So we did publish a roadmap just about a month ago, really talking about some of the work we've done in sort of setting the foundation for the program, starting to engage the ecosystem, writing a vision and strategy paper. But really what's been going on for about the last 6 months has been really sort of building the true sort of nuts and bolts of this thing, which is standing up NatCast, getting the right agreements in place, getting early engagements with the community, and sort of the foundational things that we need to do to start launching these programs. And so I am excited to say, I think my story for a while now has been, by the end of 2024, the NSTC is going to really look and feel like a real thing. We're going to be running programs, we're going to be doing work, we're going to be engaging the community. So our 4 priorities, our initial priorities, are these things. It's the facilities model and how we're going to select those facilities, the Workforce Center of Excellence, some of these early opportunities for R&D, and then opening membership, which we hope to do in no later than early fall. So with that, I will just remind you how to get involved, make a pitch. We are designing this program to truly be something that is not only sustainable, but that just fundamentally changes sort of the resources and the capabilities that we have in this country for doing semiconductor R&D, and want to make a pitch to all of you to consider being part of that, because it will really only be successful as its membership and engagement and participation. So if you haven't gotten on the newsletter, please do so. And I think we've got a few minutes for questions.
Okay, it is kind of complaint. We have got CHIP Act, but there's no funding for chip design. And I've looked at your website here and there. I sent email, I didn't get any response. So we will have the foundry, but we won't have any chip to run into them.
I'm sorry, there's no funding for what?
Chip design itself.
Chip design itself. That's certainly beyond my pay grade as far as what was and was not funded in the CHIPS Act. Certainly chip design and chip design technologies are very much in scope for the NSTC, where like the full technology stack I think is relevant. But it is true that the manufacturing incentives are focused on manufacturing.
Okay, thank you. One more question. So can you fund at least taking the chip to the fab, that part of the initial cost?
To be determined on how that's going to work from a funding perspective. Okay. We certainly want to make it easier, simpler, and with easier to access the right technologies.
Okay.
And how support will work is TBD.
Okay, thank you.
Hi, Ignatius here. I was very happy to see that RF design is up there in your chart, and as a wireless and RF designer, TSMC and others bring RF stuff in 1.3 version. So if you have fabs that do RF way ahead, even 1.0 version,
yeah,
we'll be ahead of that in the game, and in the future, a lot of signaling will be through RF. No?
That's a very good point. Yeah, thank you.
And just to follow, I think you mentioned something MPW is being available. That's what he was asking about. No?
Yeah, so we certainly do anticipate a MPW and shuttle programs, but I think funding is the part that I am not sure about. Yep.
Excuse me. May I ask, is there any special initiative for attracting overseas workforce in terms of manufacturing? Because as far as the majority of the manufacturing done in Asia, how do you attract overseas engineer or
Attracting people to this country?
to USA?
I'm not sure I have a great answer for you. I mean, I certainly acknowledge some of the, great talent around the world. I don't think there's specifically a program targeted at that today, but I will say certainly the workforce programs are just being sort of designed as we speak. So, it's
So
certainly
focus is on the developing and training the local forces for them to enter this manufacturing.
so far
field.
the early efforts are going to be about training. That's correct.
Okay,
So
understood.
beyond that, I'm not really sure.
Thank you.
Yeah, but it's a good comment.
So quick question, in one of the slides you mentioned that Intel 18A is kind of trailing compared to N3P from TSMC. So my question is, is it the cutting edge foundry process that makes US win this chips race, or is it something else?
Yeah, so to be clear, I showed two headlines, one from TSMC claiming they're better and one from Intel saying they're better. So I'm
from Intel, by the way.
I'm staying out of it. Just wanted to show a balanced view of that. I think I would agree with what I would say is probably conventional wisdom, right? Continuing, to have state-of-the-art and better process technology is absolutely a critical part of this industry and will continue to be. However, it used to be the main driver for progress, and I don't think that will be true moving forward. It will continue to be an important one, but things like advanced packaging and design, architecture design, other things will also be critical drivers.
Yeah, because building a cutting edge fab is not just a challenge in terms of funds and the know-how and the infrastructure, everything you need, but also you need customer base that can support that, right? So,
Yep.
So given all those challenges, we see what future has for us.
That's right. Thank you.
Hello.
Yes.
Hi. Thank you for a great presentation.
Thank you.
My question is about digital twins. So my experience in the industry and the conferences that I've been to, digital twin is more of a buzzword than a technical word. And from the panels that I've seen, what is a digital twin? If you ask people, it depends who you ask it.
Yeah.
And they would come with different answers. So for things like this, like what exactly is a digital twin? What exactly is AI for RFIC? Who defines this? Is this the industry, or do you have special committees that gives the technical definition of these terms?
Yeah, so I can certainly talk first about digital twins. So I think it's a fair observation. It's, what it means is sort of in the eye of the beholder in many cases. I think the Digital Twins program under the Manufacturing USA program put out very much a vision for what this institute is going to try to solve. It is more focused on manufacturing and process technology, which is not a subset of what some people use that term for. And the way that these programs work is they're actually creating a nonprofit institute made up of industry that is sort of driving the agenda of the institute itself. So what these Manufacturing USA institutes do is sort of create a framework, but it's the proposers and the members that actually sort of figure out what they want to contribute to and where those investments should go.
All right. Thank you very much.
Mm-hmm. Thank you.
Hey, Jay. So my question is about workforce development.
Yeah.
So I've been trying to engage with several universities to get them to educate, especially undergrads, but also grads possibly, on how to do this stuff, right? Particularly from my area is functional verification, right?
Yeah.
The answer that I get from professors a lot is, well, what research opportunities are there for me to be able to fund that kind of an effort? Is that something that's going to be involved in the Workforce Education Center, or like how can we address that part of it? And in terms of just developing curricula, is there going to be some office there that's going to help develop materials that professors will be able to use throughout the country?
Yeah. Great question. So, one of the things that workforce center is specifically meant to solve is that gap, right? There's a large segment of the academic community that says, supporting workforce means funding my research. That's true. That's important. We want to, we love grad students too. But it needs to mean so much more than that. And so the Workforce Center of Excellence, not to get in front of sort of the specific things that they will be announcing, but certainly training programs, curricular programs, including undergrad, best practices, and really just how to excite students and attract them, into these relevant fields, whether it's electrical engineering, computer science, chemical engineering, materials, whatever it may be, and sharing those things, more broadly. I would say I've had just amazing conversations with people who have, done their own sort of like personal effort at trying to do this with students with really cool results. And so how we can, if we can take some of those lessons and scale them out just across the industry, including chip design, as a really important need. We definitely plan to do things like that as part of this center.
Okay, a little more strategic question. I know you're ramping up your operation, your programs and everything. So this is probably for next year, but we need to start thinking this year. Supply chain traceability. We build all these fabs, we put all this investment, put billions, and then the Chinese say, I see your billions, so put the same, and I have 5x the output. So commoditizing our markets, et cetera. So we have incoming traceability of commodity chips and outcoming traceability of AI chips that could be programmed remotely. Is there any thought about that strategies coming from the top? And of course, there's the EU-US Technology Trade Council that are talking about it, and I will talk to you privately about it as well.
It sounds good. I have to admit, I caught most of what you said, and I think I got the gist of it. I think one of the things I think it's actually important for people to remember, and it's kind of why I wanted to go through this first part of the talk. I think it's important to remember where we just came from only a few years ago. So I love the fact that we're saying, oh, great, you're bringing all this manufacturing here, but what about the next problem? That's a big win. So let's celebrate for just a minute. But yes, your point's taken. It's a very complex industry. One set of investments isn't going to solve all of these problems now and forever. So would be happy to talk more about
just
some of the things you're
thinking about. Just go on top and say we need market preference. The rest will come.
Gotcha.
Right? Not just the capacity, but the preference. Okay, for people to buy the chips.
Would be happy to talk more. All right, take the last one.
Okay, my question is about the workforce, which actually you answered already. The second part is about the pricing or the cost. So obviously the industry is very much used to the fabrication and manufacturing which is taking place in Asia-Pac region. So how would this cost factor be taken into account? Would there be some subsidies or preferences given to early customers who come to the local manufacturing?
I am not the right person probably to answer your question. I'd say I know, the subsidies that are part of the CHIPS Act themselves come through tax incentives and direct subsidies for standing up these facilities. So that is one way to sort of level the cost equations. But beyond that, how pricing would work, I am not the right person to ask. And I'm not sure that, that's part of these agreements and whether those are, up to the individual companies or not. So not really sure. Yep. Thank you very much.